Alright, let's go. Okay, let's take a look at this circle here. We know that the area for a circle is pi r squared. Particularly half of the circle, that angle is 180 degrees as depicted here. The whole circle, that's 360 therefore. And so when we're looking at this semicircle, we can say that we can take that pi r squared and we can consider it as you want 180 degrees out of that 360 degrees. And we can see that the fraction you'd end up with there would be a half. So you've got pi r squared times a half, which makes sense because therefore it's the circle and this being multiplied by half, so it's half of a circle. Now, what's more important is this concept that I took the 180 degrees, which is what we wanted at the time for just a semicircle, and I divided it by 360, which was the whole. And this gave us that area for the semicircle. Therefore, we can say that this equation could be simplified down to something more useful or universal, which is that if you want the area of a sector being a fraction of the whole circle, which I'll show you later, then you could use pi r squared times what you want divided by the whole. Let's look at this example. So here, if I can make this more clear, bear with me, my brush skills are not the best, so see what I'm saying, that brush skill is awful. But anyway, hold up. Oh no, I couldn't get it, 1 second. Yes, look at that one. And I also want this one over here. Let's say that that's the sector that we're looking at. The angle theta has been given, let's say it's 30 degrees. It's a little bit more, it's a lot more than 30 degrees, but that's what we're going to go for in this diagram. Not to scale would be the phrase used. Let's make sure you've got that there so I don't get any comments. Not to scale. There you go, not to scale. We like that there. So we're going to use what we said earlier, pi r squared, what you want, which I'm just going to call the angle theta, divided by the whole, which is 360 degrees. Therefore, I would do pi r squared is being multiplied by 30 over 360. Let's say that this length is 3 centimeters, again, not to scale. Let's say it's 3 centimeters. And so I do pi 3 squared times by 30 over 360, or 3 over 36. You'd end up with something like 2.36 to 3 significant figures, or through over 3/4 pi. Let's not forget that the actual statement you want, this subscript s, is because I'm saying sector. This is a sector here. So the area of this sector therefore will be around 2.36 centimeters squared, not to forget the units. And again, the idea is that the area of a sector is the area of a circle multiplied by what you want divided by a whole. This is a simplification somewhat, but generally another way to put it in a more elegant manner perhaps would be to suggest that it's theta over 360 degrees. And we can talk about how this simplifies quite significantly if we were to put in radians, but that's for another conversation. And so this is what we need as background for a more complicated problem wherein you have sectors, but also you're trying to consider the triangles that can be found within it. Take a look at, for example,